Hello and welcome back to Engineers Olympiad, where learning meets success. We're on to second chapter of surveying, that's theory of errors in surveying. We have completed 6 video lectures of the same chapter. They're up on the channel, Engineers Olympiad. You can watch those videos before watching this video. So let's begin. We're doing numericals, as you know. So the question is, in measuring a round of angles at a station O, the third angle C closing the horizon is obtained from the relation C is equal to 360 degree minus A plus B. If the angles A and B have the standard errors of plus minus 3 seconds and plus minus 4 seconds, what is the standard error of C, or determine the standard error of C? All right. So as you know that the errors, be it standard errors or be it probable errors, they always propagate when we do some mathematical operations, and they are calculated the combined effect of the errors of the observed quantities on the computed or derived quantities found by differentiating with respect to each of the observed quantities and then summing them up to obtain their total effect. All right, so we'll do the same as we have the relation C is equal to 360 degree minus A plus B. This is given. All right. These are the angles, angle A and angle B, which have the standard errors of plus minus 3 seconds and plus minus 4 seconds. All right. So what am I gonna do? Sigma C square, standard error in C, is given by differentiating these observed quantities, and we can find the effect on the derived quantity by differentiating with respect to each of the observed quantities, and then we have to sum up to obtain their total effect, as already discussed during calculations of propagation of standard errors. So I may write it like, I will differentiate it 360 degree. All right, this is minus A minus B with respect to A, standard error in A, square of it. We have to then sum it up. 360 degree minus A minus B with respect to B, standard error in B, square of it. All right. By calculations, by differentiating it, this is equal to sigma A square plus sigma B square. All right. So standard error in C, square of it, is equal to sigma A square plus sigma B square, or I may write it down that sigma C is equal to how much? Square root of sigma A square plus sigma B square. All right. So sigma C, let me write it over here. Sigma C is equal to how much? What is standard error in A? It is plus minus 3 seconds, square of it. What is standard error in B? 4 seconds. All right. So by calculation, standard error in C is equal to plus minus 5 seconds. All right. So this was the question, and we used differentiation and we calculated the combined effect of the standard errors in the observed quantities on the derived quantity. All right, going on, let's do the next question. We are trying to solve as many numericals as possible. We have done same during first chapter as well, introduction and basic concepts of surveying. Those video lectures are up on the channel Engineers Olympiad. You can watch those videos as well. All right, question number 2. Let's see what question number 2 is. All right, so question number 2 is, in carrying a survey across a highway, across a highway, 8 readings were taken with a leveling instrument under identical conditions. The probable error of the single observation is how much? 0.01295 meters. Find the probable error of the mean. Find the probable error of the mean. All right. So the question is, in carrying a survey across a highway, 8 readings were taken with a level under identical conditions. The probable error of the single observation is 0.01295 meters. Find the probable error of the mean. All right. You know that the probable error of the single observation is how much? It is plus minus 0.6745 times the standard deviation, that is summation of v square divided by n minus 1. All right. And you also know that the probable error, or the most probable error of the mean, is given by how much? It is plus minus 0.6745 times summation of v square divided by n into n minus 1. All right, so I can say that summation, or the probable error of the mean, is equal to how much? Probable error of the single observation divided by square root of n. All right, this is the relation between probable error of the mean and the probable error of the single observation, or you can say most probable error of the mean and the most probable error of the single observation. We'll use the same relation and we'll find the solution of this question. All right, so what is given? The probable error of the single observation is this much, and we have to calculate the probable error of the mean. So we'll use the same relation. EM is equal to ES divided by square root of n. I have to calculate the probable error of the mean. That means EM needs to be calculated. What is the probable error of the single observation? It is 0.01295 meters. All right. And what is n? How many observations? In carrying the survey across the highway, 8 readings were taken. So n is 8 divided by square root of 8. By calculations, my most probable error, or the probable error of the mean, is equal to how much? 0.00458 meters. All right. So this was the question and we solved it. Moving on, let's do the third question. Question number 3. So question number 3 is, right, a plot of land (60 meters cross 20 meters) is measured with a steel tape if the standard error of length and width measurements is taken as plus minus 1 centimeters, then the standard error of the area of the plot would be. All right. So the question is, a plot of land 60 meters cross 20 meters is measured with a steel tape. If the standard error of length and width measurements is taken as plus minus 1 centimeters, then the standard error of the area of the plot will be. All right, we'll use the same differential equation. All right, and we will try to solve it. All right, because the effect of the propagation of standard errors is found by differentiating with respect to each of the observed quantities and then summing them up to obtain the total effect. All right, so let's do it. We know that area is given by length multiplied by breadth. All right, I have to calculate what? The standard error of the area. Let me denote it as sigma A. This will be by differentiating the observed quantities and then summing them up. All right, so let me write it as, what will be this? L cross B divided by, with respect to L, and the error in length, square of it, plus with respect to B. All right, standard error in B, the square of it. All right, so sigma A square is equal to how much? By calculations, it is B sigma L square of it plus, here it will be L sigma B square of it. This is L. All right, so sigma A is how much? It is the square root of all right, so this is the standard equation by which I can find the standard error in this area of the plot, and this is equal to square root of breadth multiplied by standard error of length, square of it, plus length of the plot multiplied by standard error in breadth, square of it. So standard error in the area is equal to how much? What is B? It's 20. What is the standard error in length? Both have the standard errors of plus minus 1 centimeter. This was 20 meters, so 1 centimeter is how much? 0.01 meters, square of it, plus length 60 multiplied by standard error in breadth. Both length and breadth have the same standard errors, 0.01 meters, square of it. All right, by calculations, this is equal to how much? 0.04, and this is equal to 0.36. By further solving this plus minus, please note that. So by calculations, the standard error in area is equal to plus minus 0.6324 meter square. All right, so this was the question and we solved it. All right, going on, let's do the next question. Question number 4. All right, so we're trying to solve as many questions as possible, as already told. So let's move on to question number 4, which says, all right, the angles A and B are related as the angles A and B are related as A is 5 times B. All right. If the observed value of the angle B, if the observed value of angle B is how much? 20 degree, 10 minutes, 30 seconds, with a standard error of plus minus 0.05 seconds, determine the standard error of A. Determine the standard error of A. All right. So the question is, the angles A and B are related as A is 5 times B. If the observed value of the angle B is how much? 20 degrees, 10 minutes and 30 seconds with a standard error of this much, 0.05 seconds. We have to determine the standard error in A. All right. So A is 5 times B. All right. So standard error in A is how much? By the general relation, plus minus K times sigma A. All right. As we have already studied during propagation of errors, that if a computed quantity is equal to an observed quantity multiplied by a constant K, the standard error of the computed quantity is equal to standard error of the observed quantity multiplied by the constant K. This is general relation. All right. So sigma A will be how much? The relation says that it is equal to how much? The standard error of the observed quantity multiplied by the constant K. So my observed quantity has a standard error of this much, and I have to multiply it by the same constant by which they are related. So it is plus minus 5 times standard error in the quantity, that is given by 0.05 seconds. So by calculations, it is equal to plus minus 0.25 seconds. All right. Please do not confuse yourself with why is it A and it was given as B. It is that how many times I have to look for my standard error. All right. Students, please do not confuse yourself. The relation was A is equal to 5 times B. All right. And the general expression for the propagation of errors says that if a computed quantity is equal to an observed quantity multiplied by a constant K, then the standard error of the computed quantity is equal to the standard error of the observed quantity multiplied by K. So this was my observed quantity and this is my computed or the derived quantity. It had an error of something, plus minus 0.5 seconds, and this was related to the derived quantity by multiplying it by some constant, that it was 5 times this. That means the standard error in the derived quantity will be the same standard error that my observed quantity has multiplied by the constant. Here constant K is 5, and you can, this was a general expression, that's why I wrote it like this. Otherwise you can also write that sigma A, or the error in standard error in A, is plus minus 5 times standard error in B. All right, as my relation is this, A is equal to 5 times B. All right, so by calculation sigma A was same, 5 times our standard error of B. All right. So this was the general equation. That's why it was A and A. So please do not confuse yourself. It was the standard error and it came equivalent to plus minus 0.25 seconds. Once again, I am illustrating or summarizing it for you that if a computed quantity is equal to an observed quantity multiplied by a constant k, then the standard error of the computed quantity is equal to standard error of the observed quantity multiplied by the same constant k by which they are related, and k in this case was 5. All right, moving on, let's do the next question. Question number 5. All right, let's do the question number 5. Question number 5 is, all right, it's this. The sum of angles A, B, and C is equal to 180 degrees. The observed values of A, B, and C and their probable errors are as follows. A is equal to 40 degree, 15 minutes and 20 seconds plus minus 0.3 seconds. B is 55 degrees, 40 minutes, 30 seconds plus minus 0.4 seconds. C is 84 degrees, 4 minutes, 10 seconds plus minus 0.5 seconds. We have to determine the probable error in their sum. All right. All right, so the question is the sum of angles A, B, and C is equal to 180 degrees. The observed values of A and B and C along with their probable errors are given as follows. We have to determine the probable errors in their sum. All right, so by using the general expression in case of addition or subtraction, what is my probable error or the standard error? Both have the same expression. What is it? It is in the sum will be equal to how much? Plus minus square root of EA square plus EB square plus EC square. All right, so this is the general expression that how errors propagate, whether probable errors or standard errors in case of an addition or subtraction, both have the same general expression, and it is that the probable errors in the sum will be equal to plus minus square root of summation of squares of the individual probable errors in each of the angles. All right, so my probable error will be plus minus square root of square of the probable error in A plus square of the probable error in B plus square of the probable error in C. That is 0.3 seconds square of it plus 0.4 seconds square of it plus 0.5 seconds square of it. All right, by calculations, the probable error in the sum is equal to how much? Plus minus 0.71 seconds. All right, so this was the question. We had been given three angles whose sum was equal to 180 degrees along with the observed values and the probable errors in each of the angles, and we determine the probable error in the sum, because their sum was given by, it was a plus b plus c, and by using the general expression for the propagation of the standard errors or probable errors, in this case probable errors, and it is equal to this, that the probable error in the sum is equal to square root of the summation of the probable errors in each of the angles, the square of those, and by calculations the probable error in their sum came equivalent to how much? Plus minus 0.71 times. All right, let's move on and do the next question. Probable error is 0.71 seconds. All right, this is our question number 6. So the question number 6 is, the angle A is related to angles B and C as under. They're related by this expression or the equation, and that is A is 4B multiplied by C. The observed values of B and C angles and their corresponding standard errors. As already discussed, that the modern trend is to use standard errors instead of probable errors. All right. Standard errors are as follows. B is 20 seconds plus minus 0.03 seconds, and C is how much? 30 seconds plus minus 0.04 seconds. We have to determine the standard error in A. Determine the standard error of A. All right, so the question is, the angle A is related to the angles B and C as under. A is equal to 4B multiplied by C. The observed values of angles B and C and their corresponding standard errors are this much. We have to calculate the standard error of A. All right, we'll do the same thing. We'll differentiate, then sum them up to find the combined effect of the errors in each of the observed quantities on the computed quantity or the derived quantity. All right, so expression is A is 4B multiplied by C. That means sigma A squared is 4BC with respect to B, standard error in B, square of it, plus 4BC with respect to C, standard error in C, square of it. By calculation, sigma A square is how much? Here it will be 4C sigma B, square of it. Here it will be 4B sigma C, square of it. That means sigma A is square root of 4C sigma B plus minus square of it plus 4B sigma C, square of it. All right. So this is the expression by which I can determine the standard error of A, as A is related to B and C angles by this relation. A is equal to 4B multiplied by C. Let me write it down over here. So sigma A is how much? Plus minus square root of 4. What is C? 30 seconds. Sigma B 0.03 seconds, square of it, plus how much? 4. What is B? 20 seconds multiplied by sigma C, standard error in the angle C. How much? 0.04 seconds. By calculation, sigma A is equal to plus minus square root of 12.96 plus, this is equal to how much? 10.24. So standard error in this is given by plus minus 4.82 seconds. All right, so this was the question. We had a relation between the angles A, B, and C. These were the values of the angles B and C along with their standard errors. I had to calculate the standard error in this A, and by applying the same principle of differentiating the observed quantities and then summing them up to find the propagation of standard error in the derived quantity or the computed quantity, and it came equivalent to how much? Plus minus 4.82 seconds. All right, moving on, let's do the question number 7. All right, question number 7. So question number 7, all right, it's this. If the three angles of a triangle each have a standard error of plus minus 4 seconds, what is the total error in the triangle? All right. So the question is, if the three angles of a triangle each have a standard error of plus minus 4 seconds, we have to calculate the total error in the triangle. All right. So this is the case of summation of the quantities. All right. And by the general expression, sigma is equal to plus minus we have studied this during propagation of standard errors. All right, so this is the case of addition of the quantities and finding the combined effect on the computed quantities or the derived quantities, as in this case my sigma A is equal to sigma B is equal to sigma C is equal to, say, sigma, because all the three angles have the same standard error of plus minus 4 seconds, then by the general relation, sigma is equal to plus minus sigma A n raised power 1 by 2. So sigma is equal to plus minus, this is how much? 4, all right. N, how many angles in a triangle? 3, square root of it. So sigma is equal to plus minus 6.93 seconds, or approximately, say, 7 seconds. All right, let's do the alternate method. We have to calculate the standard error in, let's call these angles as angle A, angle B, and angle C. Each have a standard error of plus minus 4 seconds. That means sigma A is plus minus 4 seconds, sigma B is plus minus 4 seconds, and sigma C is plus minus 4 seconds. What is the standard error in the triangle? That is their summation. Let me call it, let me give it a name as sigma, say S. This is equal to how much? Plus minus square root of sigma A square plus sigma B square plus sigma C square. That means standard error in the sum is plus minus 4 square plus 4 square plus 4 square. By calculations, this is equal to how much? Square root of 48, which is equal to plus minus 6.92 seconds, approximately 7 seconds. All right. So this was the general expression, and please do not confuse students yourself with these things. This I am writing on behalf of the general expressions I am using. Otherwise, the general method is the same. That in this case, it was a case of addition of the quantities and the propagation of the standard errors when we are using a mathematical operation of either addition or subtraction is the same. That the standard errors of the sum will be equal to square root of the summation of the squares of the individual standard errors or the probable errors. All right, going on. Let's do the question number 8. Question number 8. All right, so my question number 8 is this. Calculate the standard error of the volume of a cuboid whose sides A, B, and C have the values and standard errors as under. All right. A is 50 plus minus 0.04 centimeters. B is 40 plus minus 0.03 centimeters. And C is 30 plus minus 0.02 centimeters. All right, so this is the question. The question says calculate the standard error of the volume of a cuboid whose sides A, B, and C have the following values along with their standard errors. All right, so as we know that volume is equal to of a cuboid A multiplied by B multiplied by C. All right, I'll use a general expression for the propagation of standard errors. Sigma V square ABC with respect to A first, standard error in A, square of it, plus ABC with respect to B, standard error in B, square of it, plus ABC C, standard error in C, square of it. By calculation, sigma V square is equal to how much? In this case, it is BC sigma A, square of it. Here it is A and C, sigma B, square of it. And here it is A and B, sigma C, square of it. Or sigma V is plus minus square root of BC sigma A, square of it, plus AC sigma B, square of it, plus AB sigma C, square of it. All right, so this is general expression. I write it over here. So sigma v is how much? Plus minus. B 40, C 30, sigma A 0.04 square of it, plus A 50, C 30, sigma B 0.03 square of it, plus A 50, B 40, C 0.02 square of it. All right. Standard error in volume is given by this expression: 40, 30, 0.04 square of it multiplied by 50 into 30 into 0.03 square of it plus 50 into 40 into 0.02 square of it. By calculations, standard error in volume is equal to plus minus 77 cubic centimeters. All right. Standard error in the volume of this cuboid is given by plus minus 77 cubic centimeters. All right. So this was the question, and we use the same method of differentiating the observed quantities and calculating the combined effect of the propagation of the standard errors in each of the sites. All right. Moving on, let's do the question number 9. We're trying to solve as many numericals as possible. We're doing the same in each chapter. All right. So question number 9. Question number 9 is find the most probable value of the angle from the following observations. Find the most probable value of the angle from the following observations. All right. Angle A is 46 degrees, 34 minutes, 0 seconds with a weight of 1. Angle B is 46 degrees, 33 seconds, 33 minutes, 56 seconds with a weight of 2. All right. So we have to calculate the most probable value of the angle from the following observations. That means we have to calculate the weight arithmetic mean. All right. That is given by how much? All right. So this is a general expression by which we calculate this. It is given by how much? M is equal to W1 M1 plus M2 W2 divided by W1 plus W2. All right. Because in observations of equal weight, the most probable values of the observed quantities can be obtained by the theory of least squares. That is, M is equal to M1 plus M2 plus so on up till Mn divided by N. Or in other words, I can say that the most probable value of an observed quantity is equal to the arithmetic mean of the observed values of the quantity. All right. But when the observations are not of the same weight, the above equation is modified and it becomes this. All right. So let me substitute the values. So M is equal to W1, 1, measured value. M1, how much? 46 degrees, 34 minutes and 0 seconds. plus, it's 2. It is 46 degrees, 33 minutes, and 56 seconds. W1 plus W2. It's 1 plus 2 because this has a weight of 1 and this has a weight of 2. That is 1 plus 2. By calculations, M is equal to how much? 46 degrees, 33 minutes, and how much? 57.3 seconds. Alright, so I calculated the most probable value of the angle from the following observations. Alright, and W1 and W2 were the corresponding weights and the observations were M1 and M2. This was my M1 and this in this case was my M2. My observations and my weights. And I calculated the most probable value. Alright, and let me illustrate it once again that most probable value of an observed quantity is equal to the arithmetic mean of the observed values of the quantities, but when the weights are same. But when the observations are not of the same weight, the above equation is modified by this equation. And here we can find the most probable value of the observed quantity is equal to the weighted arithmetic mean of the observed values. This is known as the weighted arithmetic mean. Alright, let's do the last question for this video lecture. Question number 10. Let me rub it first. Alright, so the last question for this video lecture. Question number 10. Alright, what is question number 10? The standard error of an angle derived from 4 measurements is plus minus 2 seconds. How many measurements will be required to halve this error? Assume that the same precision is maintained. We have to assume that the same precision is maintained. All right. Let's solve it. The standard error of an angle derived from 4 measurements is plus minus 2 seconds. How many measurements will be required to halve this error if every measurement is taken with the same precision? Or we're assuming that the same precision is maintained during this entire surveying, all right, wherein they are finding the angles, all right. So I know that sigma m is equal to plus minus, all right, the standard error of the mean is equal to standard error divided by the square root of the number of measurements or observations we are taking. So here, what is this? The standard error of an angle derived from 4 measurements is this much. That means the mean was this much. How much is this? It's 2 seconds. How many measurements were taken? 4 measurements. So sigma will be given by how much? Plus minus 4. Alright. This is the general expression, and I used the given quantities in the question. That is standard error of the 4 measurements is given by how much? 2 seconds. So I calculated my sigma, it is plus minus 4. So for halving this error, we have to halve this. That means error in mean should be equal to plus minus 1 second. Alright, now how many observations we have to take to halve this error? Let's use the same general expression. Now in this case, our standard error of the mean becomes 1 second. Alright, as it's already calculated in the single observation, it will be how much? Plus minus 4 by square root of n. Now let me calculate how many observations it requires so that my standard error of the mean will be equal to 1 second. By calculations, my n is equal to 16. That means 16 number of measurements with the same precision are required to be carried out so that standard error of the mean will be equal to how much? Plus minus 1 seconds. Alright, so this was the question and we solved it. With this, we conclude today's video lecture. Thank you for watching.